Okay, welcome back to another video of building AI agents. Okay, so in the previous videos, we saw how we can make some of the AI agents using multiple tools connected to a single AI agent node. But what you have in front of you is way more complex, but still way easier to accomplish a certain task. This is known as multi-agent system architecture. What happens over here is there is one ultimate assistant. This one. I would like to call this as parent agent. And with this are connected multiple different AI agents. And the sole purpose of the parent agent is to determine and decide what task is to be delegated to which agent. The decision making is everything that it has to do. It does not have to execute the tasks all on its own. I mean, is it even possible? Can you imagine the parent agent connected with all the 50 or 15 plus tools connected to itself, and it's the only agent that has to deal with all different tasks? Well, it's just not possible. The risk of error is just too much, and it would become way more costly because you will need to call the APIs way more frequently. So it's not sustainable. That's why what we have is multi-agent architecture like this. One agent connected to multiple different agents and multiple different tools. So you might be receiving some message on Telegram, and the Telegram message goes through some steps before it finally reaches the parent agent. The parent agent then decides which agent to use. And, and once the task is delegated to the agent and the agent has produced some response, the response is sent back through this node. So what you can clearly see is the agent is connected with model, memory, think, calculator, and Tavily, as usual, along with four different agents. Now let's look at what's happening beneath the surface. Let's open the Ultimate Assistant. Here is a detailed expressions used to instruct this agent on several different situations, how to behave, how to give responses, and which agent to use for what purposes. This is all that's contained in this particular system message. Now, if you look into the child agents like the email, calendar, contact, and content creator agents, you would see that they are not directly connected to the parent agent. Instead, they are standalone standalone elements. Like this is not connected directly, right? Instead, the parent agent is connected through this medium. This is a workflow. This is a workflow. So what's happening over here is this node is directly calling this particular agent. So you can think of this as a call that the parent uses to use this agent. And the same with every other agent. These are like the calling mediums, right? So in every email agent or every child agent, there are some more instructions in the expression. For example, email management tools. Use send email to send emails. Create draft. The user asks for a draft, etc. So in such multi-agent system architectures, we need to define the instructions really carefully so that the agents are not confused and they are clear with what they are assigned with. So with this, I hope the underlying logic of multi-agent system architecture is clear. It's not very difficult, I would say. It's just like a nested loop, a loop within a loop, like you might have studied in your data structures and computer science. It's an agent within an agent that uses multiple different agents for different purposes and tasks. Here we have some benefits of multi-agent system. Like you can see, you have more reusable components. What this means is that you just have to make this particular child agent once, and you can use this same by calling it via using this node. Okay, so this one call is all that you need to use this agent. So you can reuse the components. Model flexibility, of course, because you might have noticed each different agent uses a different model, and the model determination is usually based on the difficulty of tasks that the agent needs to do or some other purpose that a single model or a particular model is better doing at. So yeah, all these have different chat models depending on the usage and requirements. Easier debugging and maintenance. Of course, when you have everything structured out in a certain way and have everything organized, much more easier to debug and maintain the system. Clearer prompt logic and better testability. Foundation for multi-turn agents and agent memory, of course. So this was a conceptual video to guide you through the multi-agent architecture. It's not much difficult. It just looks big and complex and something that you might get confused in, but it's not. With practice, you are gonna master this. And but yeah, we're gonna do one in this tutorial as well. Let's meet in the next video and make one multi-agent system ourselves. Till then, take care.